So today's topic is Introduction to Data Structure. So in this topic, we'll be covering all these questions. What is data structure? Need and importance of data structure, types of data structure, and why data structure is important in coding interviews. So the first thing is, what is data structure? So you can see that data structure is the particular way of organizing data in the computer so that it can be used effectively. So what does this mean is like every software that you have in your computer is somehow managing a data, and it's about managing and organizing the data in a way that data can be easily handled, easily retrieved, easily stored, and easily organized. And it has two things. The one is the space complexity and time complexity. So the space complexity mean how much storage the data is being used, data is using to retrieve or like store in your memory, and the time complexity means like how much time it is taking to retrieve data or manage or update data or store data or fetch data stored into your memory. And why it's important, what's the importance of data structure? So data structure is important because of this operation called CRUD operation. So CRUD operation is actually create, read, update, or delete operation. It's a acronym. In the computer world, you will see this CRUD operation all the time. So this means is a create, read, update, and delete. So it's all about creating a data, reading a data, updating a data, or deleting a data. So data can be stored in any places into your memory or database or any internet devices. So the data structure is important when you have to retrieve or create, update, or delete data. And it's important because it helps in reducing the time and express complexity of different tasks, right? Okay. Now types of data structure. So data structure can be divided into two types: linear data structure, non-linear data structure. In linear data structure, you will see the example like array, linked list, stack, and queue. And this is further divided, linear data structure is further divided into a static and dynamic data structure, linear data structure. In the static, you'll see an array, and dynamic, you'll see a linked list. So linear means it is arranged in one fashion. So data will be structured in a line. You can imagine in a queue. So for example, 1 or 2 or 3 or 5, 4 or 5. So these are like a linear structure. So you are storing the data linearly. Okay, and again, when about the dynamic and static, the difference is like for the static, the memory size of where you are storing the data won't increase. Like if it is a static in an array, so array can be a static and dynamic, and be a static and dynamic array. So a static means the size of the array is fixed. If size of the array is fixed, so once I say, let's say I have a size of array 10, so I can only store 10 items in this array. But if I want to increase, it won't increase because the size of this array is fixed, so it's called a static. But we have a dynamic array. So dynamic array means you can increase the size based on your, so you don't need to define the size initially. So size is not defined. Size is not defined, is not fixed or defined. So you can store as many items as you want, right? This is the difference between static and dynamic. And coming back to the non-linear data structure, so non-linear data structure is like the example is like tree and graph. You can imagine the tree. A tree can be like let's say you have a root 1, and then you have 2 here, and then again you have 3 here. So this is like a tree structure. Tree will have one root node, and then the root node is like a parent node, and then you have a child node. So these 2 and 3 are the child of 1, right? And 2 and 3 is the sibling, because they have same parent. So these kind of data structure are called tree structure, and you will see this tree structure when you have a relation between one or two items in the data. So for example, here 1 has a relation with 2 and 3, and 1 is the parent of 2 and 3, and 2 and 3 are siblings. So this is like a representation in a tree. And what is graph? So the only difference between graph and tree is the graph is cyclic and the tree is acyclic. So here you can see it forms the cycle 1, 2, and 3. There is a cycle in this structure. So this is like a graph. But if I just remove this, it becomes acyclic. So this is like a tree. So this is the only difference between tree and graph. And coming back to the fourth question, why data structure is important in coding interviews. So the first thing is they want to assess the candidate ability to solve the problem and their logical thinking. And the second is how much coding, what's the level of the candidate in the coding part. So the first is like, even if you don't know the coding and you know data structure, so it gives you the idea of how to solve the problem. You can logically think, you can define the problem and find the logical solution to that problem. You can say a pseudocode. You can create a pseudocode, and you know the data structure very well. You can create a pseudocode, and that pseudocode you can convert into the code. So this two part is important in the coding interview. First is you will be given a problem, and then you have to provide a solution. And from that solution, you develop a pseudocode. And from that pseudocode, you will be writing a code. Okay, so this is kind of important part in coding interview as well. The first part in the coding interview itself will be the data structure. So that's all for today. So this cover everything about the introduction to data